This tutorial looks at drinking water, where we get our drinking water from in this country, why it's important to conserve water, what materials are still found in drinking water, and how we can test for certain ions in water. As usual, the specification content is on these black slides, and the first thing we need to know is where we get our drinking water from in the United Kingdom. Our idea of fresh drinking water in the United Kingdom may be very different from other people's idea of fresh drinking water in their own countries. British drinking water comes from four main sources: from lakes and artificial lakes called reservoirs, from rivers and from wells, including aquifers, which are wells where the water comes naturally out of the ground under its own pressure. We use an enormous amount of water at home, not just for drinking, but also for washing ourselves and our clothes, for flushing toilets, and for watering our gardens and washing our cars. Industry uses water in various ways. For example, the vegetables that you buy at the supermarket have all been washed, which requires an enormous amount of water. It's used as a coolant in power stations and also in a solvent, for example, in the dyeing industry for textiles. So it's important to keep an eye on how much water we use. That's because whenever we have drinking water, we've used chlorine to treat that water, and we can reduce the amount of chlorine that is manufactured and the amount that goes into, therefore, our rivers and seas if we can conserve the amount of water that we use. We also save energy and money by having less water supply, and if you're on holiday in Africa, for example, where the water supply comes largely from underground wells, then by using less water you allow more water to be available to local people. Although our water supply is pretty pure by world standards, our water will always contain various pollutants such as nitrates, lead compounds and pesticide residues. Nitrate residues come from the overuse of fertilizers on fields. The nitrate fertilizer gets washed into rivers and lakes and therefore ends up in our water supply because nitrates are very soluble and difficult to remove from water. Lead compounds can sometimes come from old lead pipes leading into Victorian houses. Most modern houses now have plastic or copper pipes, so this isn't an issue. And pesticides come from spraying pesticides too close to water resources and then being blown into the water or washed into the water, where again they're difficult to remove. Before the water comes through our tap, it has to be purified because river or reservoir water will contain many dissolved salts and minerals, some of which may be poisonous, will contain microorganisms, pollutants and insoluble materials such as sand and grit. Before the water comes through our taps, it goes through three main processes. The first one is sedimentation, the second one is filtration, and the third one is chlorination. And only when it's been through these three processes is the water fit for drinking. Sedimentation, allowing the water to sit in large tanks, allows some of the large insoluble solids to separate out. The smaller pieces are then removed by filtering through usually sand beds. Once the water is clear of solid pieces, however, it still can contain microorganisms and therefore it's chlorinated by bubbling through chlorine gas, and this kills the microbes in the water. These processes don't remove dissolved salts and minerals, some of which may be bad for us, like lead or cadmium, but many are good for us, like calcium. It also doesn't remove pollutants. Some of these will be very soluble and difficult to precipitate out. For example, nitrates from fertilizers are toxic in large quantities. Here's a past paper question. Rivers and reservoirs are two sources of drinking water. Write down the name of one other source of drinking water in the United Kingdom. Well, I'm going to go for aquifers. I could have gone for lakes as well. Water from rivers sometimes contains dangerous microbes. These must be killed before the water is safe to drink. How are these microbes killed when water is purified? They are killed by chlorination. And there's the answer. We could have had lakes, aquifers, wells, springs, canals or streams, but certainly not seawater or tap water in this country. And it's killed by chlorine or chlorination. Now a section on testing for ions in water. The first of these is by using a barium chloride solution to test for sulfate ions. You need to know the name of that reagent, barium chloride, and you also need to be able to write word equations for the reactions. Now, an experiment that you might do in school would involve using various sources of sulfate ions, such as potassium sulfate, sodium sulfate and copper sulfate, all soluble sulfates, and adding to them a few drops of barium chloride. Now, I'm not going to fill in the entire table because the results are the same for each of the set of spaces. The name of the precipitate which is formed when potassium sulfate meets with barium chloride is barium sulfate, and this forms a precipitate because barium sulfate doesn't dissolve in water, it's insoluble, and the colour of the precipitate is white. And this is the same for the other two cases. Writing word equations, well, potassium sulfate and barium chloride will give us barium sulfate, and in this case potassium chloride solution. Sodium sulfate and barium chloride will again give us barium sulfate, but in this case the remaining solution will be sodium chloride. And finally, if we'd used copper sulfate and barium chloride, we'd get barium sulfate, again a white precipitate, but in this case we would get copper chloride. So as you can see, the word equations are broadly similar in each case. Always the precipitate, which is barium sulfate, shows us that sulfate ions are present. Finally, we're just looking at the use of another solution, this one silver nitrate solution, to test for another kind of ions, halide ions, specifically for chloride, bromide and iodide ions, again by a precipitation reaction. An experiment you may have done at school is to add silver nitrate solution, drop by drop, to solutions of, for example, potassium chloride, potassium bromide and potassium iodide, sources of the halide ions. In the case of the chloride, you get a white precipitate, whereas with the bromide you get a cream precipitate, and with the iodide a pale yellow precipitate. Different coloured precipitates because we're getting different precipitates being made in each case. In the case of the potassium chloride and silver nitrate, here the precipitate is of silver chloride. With the bromide we get silver bromide, which is the cream coloured precipitate, and with silver iodide, that's why we get a pale yellow precipitate. Now the fact we get these different coloured precipitates allows us to be able to tell which halide we have in solution. So if we had an unknown solution and added silver nitrate to it and we got a cream precipitate, we'd know that solution contained bromide ions. If it gave us a yellow precipitate, we'd know that that solution contained iodide ions.